in the lab, and of course we want to continue.
So what about university funding? Are they still behind you, or have they backed off? Or
A university, there are very few universities that fund research projects. Universities don't do that. A university will provide a working space for you, and in exchange, you're supposed to bring distinction to the university. But more than that, what else you are supposed to bring to the university is money. So if I apply to the National Institutes of Health and I get a grant, they tack on an extra 50, 60, 70%, depending on which university. And that goes to the university to pay for toilet paper and lights and janitorial services and what have you. So the university is thrilled if I get money from the National Institutes of Health. If I get a big bundle, they're very happy to receive the money. If it's private funding, it's a bit different because, for example, I know that you're extremely wealthy, Owen. If you were to, donate a few million to my laboratory as a gift, the university gets zilch, zero. It goes directly to my laboratory. So the university is more enthusiastic in situations where they can get this so-called overhead because it helps run the university. And so universities are always happy. The more money that you bring in, the happier they are, especially if it's not private money. And private money is good too because, the bottom line, they can say, oh, this year we've exceeded $2 billion in research money. And universities are competitive with one another. They want to say that we're number one, not we're number 36. But in my own particular case, it's I'm not sure how much to go into this, but there are some people at my university, including my department, who have studied themselves in the past water or use water, and they don't particularly like our findings. And some of those people are people who have some control and power, and there have been some difficult times. And there are also, I should say, there one person who wrote a paper, a scientist at our university, a fellow who I know reasonably well, and he said, well, it's all nonsense. There are other trivial explanations for what we found. And a few people have followed his paper and suggested, yeah, he's on the right track. And so it's not all gold. There are detractors, and I'm happy that there are detractors because it lends a kind of significance to it. And again, we go back to Albert St. Georgi, and another one of his of my favorite quotes of his. He said, when he got an idea, he knew. He said he knew that the idea was really significant only if the responses were highly polarized. So right. Some people hated it with a passion, and other people loved it.
That's a human experience. I mean, that's, in order to verify something, you have to have, the antithesis, coming at you, and that's really what verifies it. But I don't want to take up a whole lot. We got a little bit into what's stirring your imagination, but I'd like you to talk a little bit more about salt water and how, if any idea comes to mind, on how we could generate energy with water.
Energy.
Jim and I and Star, we've been involved with a guy named John Vadini that was, on to free energy here. He's taken out of the picture 5 years ago. Bruce Tanio, who does a whole bunch of agricultural products, and he was taken out of the picture 7 years ago. And now we've got a guy that can build one of these things, but maybe we need to shift our direction. And this is two questions again. Number one, about the energy that could come from it. I mean, you think that the water could be like a battery, right? Yep. And it could be powered by a solar panel or just by UV or what?
Yeah, okay. But my first question, when you said taken out of the picture, it sounded to me like you think he didn't pass naturally or something like this, or maybe I'm probing too far. Okay, I'm with you. Yeah, so it's actually simpler than that. I mentioned earlier that if you put in the water, put like a gel or some hydrophilic surface, that you get EZ next to it, and that EZ is typically, not always, typically negatively charged, and the region beyond has an equal positive charge, because this arises from the splitting of water molecules. So you've got separated negative and positive, and it's a battery, right? What's a
Right.
battery if not separated
Negative, positive.
negative, positive charges?
Right.
And so in theory, if you stick one electrode in the negative and another electrode in the positive, you ought to be able to get current flow out of that.
Yeah.
Now, that's in theory, and I got to tell you that we did demonstrate it in the laboratory. Exactly that. We put one electrode in the negative, one electrode in the positive, and we can light an LED, for example, with the electricity that's coming. So basically you're taking just water and the energy, it's infrared energy mostly, that lands in the water, absorbed by the water, that's fueling this battery. And from the battery, we did demonstrate that you can get electrical energy. So, but this is, I'm sorry, Jim, your brow is furrowed.
Yeah,
Not clear?
I know it's very clear, but two things come to mind. So comments from you would be very helpful. Number one, in a battery, as we understand it, there are the two poles, as you've mentioned, but there has to be a surface between the two to separate them. Otherwise, it doesn't work.
Yep.
Or you get a short circuit.
Right.
And second, if there's incoming infrared energy, let us say the sun, for example, then the energy, well, put it this way, water would then become a solar battery without need for solar cells in between.
Absolutely. All of the above. Yeah. And so the first, your first question or comment, you actually don't, in theory, mostly you need some kind of barrier to keep the positive and negative separated. But that's the beauty of this, of what happens naturally with the water. The charges are separated. And the reason they remain or can remain separated is, you know, you got the protons, positive charge in the bulk water. Each proton sticks to a water molecule to form a hydronium ion, right? And hydronium is, it's like positive water molecule. It's water with a proton tacked on. And that water, that positive charge wants to go desperately back into the EZ because EZ is negatively charged, but it can't get there because it can't go through those hexagons. It's blocked. And see, so it remains separated. Of course, you know, it'll wear down with time, like everything does, and you need a constant flow of energy to keep those charges separated. So anyway, so in response to that part of your question, the barrier that you're talking about that you need between the positive and the negative is actually those hexagonal sheets, which don't let the hydroniums back in.
Right.
So you've got this separation. And now tell me again, what was the other part of your question?
That solar energy, if we take the sun as a source of infrared, would produce energy in the water without the need for inverters and photovoltaics and all the rest of it.
Yeah, it's direct. It's all you need is water, and you need a hydrophilic surface and light. Infrared light, which is, as I said, it's all around us.
Well, the moon, I mean, infrared light exists in the dark, right?
Yeah, in the dark, exactly.
So
sure.
We don't need the sun even. I mean, the sun generates it, but
well, yeah, but the sun, 50% roughly of the sun is energy, is infrared energy.
Right.
And so the sun really does help. Yeah, it's not a necessary condition, but if you want to get something out of it, it's useful to have sunlight. But having said that, I also want to mention that there's the so-called, maybe you've heard of this, the Valley of Death. In the valley, it's a deep valley that sits in between a laboratory observation and something practical. And you got to cross that Valley of Death without dropping into it. And it's a deep, dark valley, 130 degrees or something like that temperature. And I've learned, having been involved in this company and such, that it's not trivial. There are all kinds of things that get in the way. And engineering development is something altogether beyond scientific exploration. So we're learning that, but nevertheless, the principle has been demonstrated. We know that we can get energy out of water and sunlight, or water and infrared energy, and whether it can ever become practical, I don't know. I'm not a magician. I can't produce things that we haven't produced yet, but I'm hopeful that it can. And one of the reasons for that is I think that this energy is used in our body. So we've got easy water that fills our cells. It's negatively charged. All those negatively charges repel each other. They want to get away from each other. And that constitutes, this concentration of negative charge is potential energy. And question is, does our body make use of that potential energy? Most of us have learned in the textbooks that all our energy comes from ATP. That idea, as I think you guys might know, has been challenged by Gilbert Ling, who said that that 1 year after the idea came forth that ATP has a special high energy bond, phosphate, that someone published a paper saying, oh, 1 year ago, those guys screwed up. Their arithmetic was wrong, and there's no such thing as a high energy bond. And Gilbert points out in his website, which is still ongoing, that nobody's ever seriously addressed that challenge. So you have a paper that says all the energy comes from high energy phosphate bond. Next year, a paper comes out, that's wrong. That's where we are, and all of this happened 70 years ago. So we don't really, approximately 70 years ago. So we don't really know for sure about ATP and whether it provides all the energy, some of the energy, or what. But there's this other possible source of energy, and that is electrical. And our body is just full of electrical kinds of things. And so the question is it possible that the energy that we need and use is coming in part, at least, from the easy water, which is an energy source. So it's not just electricity from water that we're talking about. It's in our bodies. It's also, in a sense, it's electricity from water. And I think that it's quite possible that we get a good portion of our energy from that. So, wow. Long answer to a short point.
No, that's also, but I think we're down to number 10 here. It says, how are you and your time in the lab doing? We really care about what you do, but above all, your well-being. Can you address that at all or not?
Well, that's a very complicated question.
Okay, how much time are you spending in your lab?
Almost zero. I am almost zero. And but the students in the lab, so the situation in the laboratory, I don't need to tell you about COVID, and we're under restrictions, and we can't have more than 3 people in the lab at any given time, and it becomes cumbersome to figure out who's going to be there when. But the students, postdocs, are making progress, and we of course have some interesting results. If you ask me about pH, please, I want to tell you about it, but I don't want to digress. So there are some students working in the lab, and for me, I had some health issues that set me back for a little bit. I wrenched my back, and I happened to get a mild case of COVID. And my house is full of mold, which means my lungs are full of mold. And my various physicians and naturopaths and whatever have been working on me, and I'm sort of back to health now. I think pretty much close to completely, but it doesn't matter because I do all my work. My laptop is my center of activity, and so it doesn't matter where I am. If I'm in my office, I can use the laptop. If I'm where I am now, which is not home because my home is being remediated from mold and they've evicted me for the time being. So it doesn't matter. I can do whatever I do from almost anywhere. And that's what I'm doing. So I have not been a hands-on person in the laboratory for some time. I just can't, I interact with the students and postdocs and they do the hands-on work. It's just impossible to do everything. I don't know about where you live, but in Seattle, the day is 24 hours only. And we're trying to do something about that, but that's the problem. So anyway, I'm up right now, at least for the next probably a month and a half in Bellingham, Washington, which is not far from the Canadian border, courtesy of a friend of mine who is allowing me to use her apartment. Yeah, so, but the lab is humming. It's not humming as loudly as it would if everybody's there at the same time, but it's moving along. And I gotta just tell you about the pH experiment because it's really
Absolutely.
fun. Yeah. Okay,
Please.
you guys know about pH. So let me ask. There are three of you, and let me start with the question. The question is, if you have, let's say, a high pH, means you got a lot of protons, right? And you got a beaker with this stuff. Is the solution positively charged, net positively charged, or is it neutral? And I would like to hear your guess because your guess might or might not be wrong. What do you think? I would start with you, Owen. What's your guess?
I would say it's positively charged for sure.
Well, okay, then you will disagree with the most prominent physical chemist who will tell you that it's impossible for any container of water to have a net charge. Star, what about you? What do you think?
Well, I would have said more positively.
Okay, but okay, we haven't gotten to Jim yet. Jim, what do you think?
I need to ask a question before I answer.
Okay.
Are we talking about bulk water out of a tap?
Yeah.
Well, then I think it's not quite as obvious as it might appear. And number one, the water is susceptible to a wide variety of contaminants that are normally found in tap waters, which will affect
Okay. Yeah,
pH.
but let's say the water is free of contaminants. Well.
So it's a theoretical model then, because that doesn't exist in the real world.
Okay, it's a theoretical model. You can add the contaminants if you like.
What if it's distilled water?
But I don't mean this to be a sort of side issue. It's a really fundamental. And you're waffling a little bit. Let me just respond to these two guys who are pretty sure of the right answer. But let me ask you, HCl, H plus, Cl minus, right? It's an acid, and you're telling me there's net positive charge, but half the people I ask will say, no, it's impossible because you got H plus and you got Cl minus, and they balance each other, and it should be neutral. So give me a response to that.
Well, when you've got acid and water, or just acid alone, you've got a negative charge because it's a low pH.
And
Well, positive charge, you mean then? Yeah.
Well, pH is a scale, what, 1 to 14?
Yeah.
and isn't it about how much acid or alkaline?
All right. Let me cut to the chase. I asked this question to many people, mostly students who come in just for fun. And 50% of them will say, yeah, it's got a positive charge because of all the H pluses. And the other 50% will say, oh no, it's got to be neutral because everything is neutral. So we did experiments and we just submitted the paper yesterday. And the answer is that all acids have net positive charge and all bases have net negative charge. And I think our experiments are done with great care. So you guys are right, but you find that any physical chemist who's worth his salt will tell you it's impossible. So I just wanted to tell you about it because it's exciting.
The bottom line is we're all out of the box, you know, and we're all care about what's going on and we're all out to make a difference. You know, that's the same page. We're all on that same page.
We are.
Whether it's energy, whether it's health, whether it's water.
Totally.
You know, and so we so appreciate your time, Jerry. I mean, I'm just almost in tears with all the time you've given us today because, you know, when I met you, it was just like, you know, I felt like, you know, this is one of the greatest people I've ever met. And
oh, you're very kind. Oh,
no, I mean it. And so if we were to channel some funds your way, which, you know, may or may not happen, you know, should it go to the lab? Should it go to Fourth Phase Incorporated? Should it go to the venture scientists? Or what would be your preference?
Well, Fourth Phase is out of the picture.
Okay.
If it has to do with water specifically, we could use the money in our laboratory. If it has to do with science in general, then IVS would be the place because IVS deals with all kinds of science. Not water would just be one of a gazillion different possibilities. So, and by the way, the Institute for Venture Science, the URL is very simple. IV Science, where IV is just like intravenous, except it's Institute for Venture, intravenouscience.org. And I'll be happy to respond to that. And, you know, if it's my lab, my email address is all over the internet. It's impossible to avoid it. And I get too many emails. I'm trying to figure out how to solve that problem. I have this terrible problem. I can't avoid answering emails, no matter who writes to me. And so, you know, I've been dealing with a high school student in Germany doing an experiment, and I can't say, no, I'm too busy. So this is my downfall because it's driving me nuts.
Well, I think people understand that you're very professional in your out of the box way.
Well, thank you. You guys are very kind, and I really thank you for those wonderful comments and support. And I hope you still think so after my next 2 books come out, which are
two.
Yeah, I'm waiting. I'm just waiting for my one is completely done, and the other is close, and I'm waiting for my son, the artist, who is the one who illustrated my Fourth Phase book. He's amazing, but he's busy remodeling his house, and his wife is getting a little bit tired of the whole family of 4 living in 2 rooms, and so there's a bit of subtle pressure that is I can sense it. So I don't want to put any more pressure on him to get this art done, but hopefully soon. And of course, the ideas in those books are how should I say? I hate to use the word radical because as scientists, pardon?
Cutting edge.
Well, cutting edge. We're in search of truth, you know, and you know, sometimes what is purported to be truth it doesn't work, and so you need to turn it over and begin again with some. And those 2 books are doing that in several different fields. So I hope. I'm sorry.
Are you building more or less in the same direction on the last book, A Fourth Phase of Water, or you going another?
Yeah, well, some of it kind of starts building that way. The first book has to do with the role of electrical charge, and easy water is involved with that, but it goes way beyond easy water, because charges are just all over around us,
Right.
and the forces that those charges can generate are humongous.
Right.
And we meaning scientists, have not taken into account charges, I think, as they should. And I deal with a whole bunch of different topics where I think charges are deeply involved. The one that's closest to water is the weather. There'll be 4 chapters on what's weather all about, and it's really, really odd. But you try to look in Wikipedia or some other place to find out about weather, what causes, what turns on the rain, why do clouds float, you know, and you won't find answers to it because they're not being
What is
addressed.
God?
Well, yeah, what is that? So that's how do birds fly, you know, is in there too. And
Okay, we got to wrap this up. My techie's getting ready to leave.
okay, anyway, thank you so much.
I want to put in a plug for your Fourth Phase of Water book. It's available on Amazon and also on our website, Sunlight Bioelectric. And it's, you know, if you want to understand water, or even a little bit or a lot, it's a must read for any student or academician or conventional scientist. I don't know if they'll read it, but Jerry, thank you so much for your time. And maybe we'll do this again, and
Sure.
hopefully we can stay in better contact than we have in the last couple of years.
That's my fault. I'm just too busy. Anyway, it's great to be with you guys.
All right.
I
Thank
love
you.
you all.
All right. Love you too, Jerry.
Okay, take care.
You too. Bye.
Bye.